This section covers implicit differentiation. It's basically an extension of the chain rule, product rule, things we already covered. But what it does, it throws in the x's and the y's all in the same equation, sometimes on the same side. So it makes it a little bit more complicated, but the ideas are still the same. If they give us this equation, for example, 4x to the second power times y plus 9 times x plus times y to the second equals -5, and I try to find the derivative all the way across. The derivative with respect to of y with respect to x, I would take the derivative of this plus the derivative of this equals the derivative of that. This part right here, the 4 I can take out because that's just the constant. How do I find the derivative of x squared times y? Well, the derivative of x squared times y that would be a product rule. So this would be the first times the derivative of the second. What's the derivative of y? Well, dy dx. Plus the derivative of the second, which is just y by itself, times the derivative of the first. The derivative of the first is 2 times x. Yeah, 2 times x. 2x. Solving this out, this comes out to be, let me see. This is 4 x squared dy dx plus 2 xy. That's just this part right here. Now we're going to add the derivative of this right here. I'm going to pull out the 9 like I did before. I'm going to take the first times the derivative of the second, which is 2y, and then take the derivative of the inside, which is dy dx. 2 dy dx. That's the first times the derivative of the second. First times the derivative of the second, plus the second, which is y to the second, times the derivative of the first. The derivative of the first is this part right here. It's just the x, so it's a 1. Now we distribute this again. This is 4 x to the second dy dx plus but if I distribute this 4 out into this and this actually comes out to 8. There. It's an 8. 8 xy plus this comes out 2 times 2 is 4 times 9 is 36. 36 36x dy dx, 36xy dy dx plus, and take that back in, so it's 9 squared. And that, and when I take the derivative of -5, that gives me 0. Now I can pull these two together, this dy dx and this dx, and those two to the other side. So on this side with 4, put a dy dx over here, and it's 4x to the second power plus 6 x1 dx is equal to, I'm going to take this to the other side, so I'm going to subtract an 8xy. To the side, it's just minus 9 squared. I'm left with. On this side, notice I can pull out a dx dy, which is what I want. Eventually, I just want to solve for that. So I'm going to pull out a dy dx. On the inside, if I pull out in here, on the inside left 4 x squared plus 36 x is equal to negative 8 xy minus 9y squared. Check my powers, everything's fine. To solve for dx dy, I divide this side by this monster here. But what I do to this side to cancel out, that side. So on this side I divide by 4x squared plus 36 xy. That looks okay so far. I can probably simplify this side. On this side I'm left with just dx dy, which is what I like. dy dx, sorry. On this side I can probably factor something out. On the top I can factor out a negative y. If I inside, I'm left with 8x plus 9y, right? I took out one of the y's. Bottom, I factor out an x and a 4, so 4x. I was hoping that would cancel out, but they don't. It's x plus, that's a what, a 6y left with in there? 6, no, 9. Left with a 9, because 4 times 9, 36, I'm left with a 9y. Almost, but no cigar. Check and see if I messed up somewhere. The 8, then I messed up with the 8 somewhere. No, that's right, okay. So that's as far as I can go. Negative y, 8x plus 9y, 8x plus 9y, all over x over s plus 9. That's my final. I don't see any other thing I can do to minimize that. Let's do number 2 using implicit differentiation. Problem number 2 says x cubed plus cubed is equal to 15x. Again, notice, and they're looking for dx. Notice that there's x's and y's on both sides. And you can't really try to solve for y, so you use implicit differentiation. We take the derivative, trying to find the derivative dy dx. To do that, the derivative of this, 3 x squared dx, dx, so that's the derivative of that, plus the derivative of this is 3y to the derivative of y, which is dy dx. That's equal to, now this is a product rule. First comes the derivative, which is dy dx, plus the second, which is y, times the derivative of the first. What's the derivative of x? Just 1. So that stays the same. So I'm going to distribute as much as I can. This is a 15x dy dx plus 15. On this side I have 3x squared plus 3y squared dy dx. I want to move all the dy's dx's to one side, everything else to the other side. So I'm going to 15x dy dx. This side I'm going to left 3y squared dy dx. I'm going to subtract from this side, getting rid of So I'm left with minus 5 dy dx on this side. And at the same time, I'm going to subtract 3. I'm going to subtract 3x squared to get rid of it from this side, and put it on the other side. So on this side, I have y that stays there. I'll bring the other side by subtracting it. Weird. I'm left with that. Now I pull out a dy dx. This side I'm left 3y squared minus 15. That's equal to 15y minus 3x squared. Divide both monster. What that does is this part out. What I do to one side, I do to the other side. So I divide this side by 3y squared minus 15x. Now, there's here, but to be honest, I can't do anything here. I can pull out a 3, and I can pull out a 3 from both the top and the bottom. If I pull out 3 on the top, I pull out a 3 from here, I'm left with 5y minus x squared. If I pull out a 3 from the bottom, I'm left with y squared minus 5x, right? No, minus 5x. Notice the 3 on the top, cancel the 3 on the bottom. So, I'm going to write it up here. My dy equal to 5y minus x squared over y minus 5y minus x squared, y squared minus 5x. That is my final answer. Number 2. Number 3. Number 3. Where is number 3? Number 3. Number 3, I have 8xy plus y squared equals x plus y. Again, x's and y's on both sides. So to find dy dx, I have to use implicit differentiation. This is a product rule. So this is 8 on the outside. First times the derivative of the second. First times the derivative of y dx plus the second, which is y, times the derivative of the first, which is just 1. That's that part here. This part is the derivative of this, which 2y, and then derivative of the inside, which is dy dx. Derivative of y is always dy dx. The derivative of x is 1. The derivative of y is dy dx. I'm going to distribute this 8. That's 8x dy dx. For the sake of time, actually let me just distribute it. Plus 8y plus 2y dx equal to 1 plus. Move all the dy dx's to one side, everything else to the other side. So here I'm left with x dy dx on that side. I'm going to subtract that, put it. I'm going to leave this here, plus 2 y dy dx. So I got that. Got that. Now I'm going to subtract this on that side, dy dx. Our x's are on the side. Now move that to the other side by subtracting it. This stays the same. That becomes minus 8y. So everything's accounted for. Here I can pull out a dy dx. I'm left with dy dx. Parentheses, I have x plus 2y minus 1. This side I'm left with 1 minus 8y. To solve for dy dx, I divide by this monster here. 8x plus 1. The reason I do that, the top cancels out the bottom. What I do to this side, I have to do to this side. So this is 8x plus minus 1. I can't really pull anything out. So dy dx is equal to 1 minus 8y over 8x plus 2y minus 1. Number 4. Number 4, we have parentheses 7xy plus like a real hoop. Looks like lots of fun. No, that's lots of fun. Again, we have x and y, so our derivative is going to be a little complicated. This is a big monster to start off with. This is one big function to the second power. So we bring the 2 down. 7x plus 4, that's a take 1 away from that, so that stays the same. Now we take the derivative of the inside. That is a big monster. You have to take the derivative of that and that derivative of that. That's going to be 0. But on that, it's first, and pull out a 7. First times the derivative of the second plus the sin, which is y, times the derivative of x, which is just 1. And then the derivative of 4 is 0. That's equal to the derivative of this. That's a 1, so that's. Let's simplify this just a little bit. 2xy plus 4. Please. This becomes 7x dy dx plus y. If we distribute this all the way through, this is equal to 14. So we can maybe make this a little bit easier. Let's do this. Let's do 14 and take this 2 and distribute it. 14xy plus 8. It's that parentheses. This parentheses divided 7. 7x dy dx plus 7y equals 14. We're getting rid of some of the parentheses. Now this is, oh, what a pain. Now I gotta take this, distribute this way, and then take this and distribute it that way. It's gonna be painful. 7 times, what is this? Let's do this part here. Let's do 7 times 14 to start off. this here. See what happens. So with 14 times 7, it gives us 98. So it's 98 xy times x times dy dx. That's the first one. Now we have to do the second one. So it's plus 14 times 7, which we found is 98. 98 the numbers, and then we have xy, and then we have y. Then we take the 8, multiply times the 7, 56. 8 times the 7 is 56. X, so we're doing this now. 56x dy dx. Take the 8 and we distribute it to that one. Plus 8 times 7 is 56. Y equals 14. Doesn't that look like a lot of fun? I'm very, very sarcastic. Combine these two here, move these two to the other side because they only have the dx dy's. So I'm gonna do it real quick. I'm gonna take a dy dx from here, dx from here. dy dx. Divide those two. Here I'm left with 98 xy x, so this is x to the second. Took the dy there. If I put x out of here, that's just 56 x. Took that out. Subtracted this to the other side and the other side. So this is 14 minus 98. Notice what happened from y squared. This is x, y to the second. Accounted for. It's accounted for. That's accounted for. dy dx is on that side. And I'm also subtract a 56y. That's that side. Now I divide both sides by this monster. Again, y, which is side. I'm allowed to do that as long as sides. So this cancels that, left with dy dx on this side. That's equal to 14 minus 98 x squared minus 56y over 8 x squared y plus 56. I can, on the bottom, I could take out an x. I could probably take out a couple of numbers. Some factors of 1498, I can probably cancel some of those out. What are some factors of 48 and 98? Let's see if 98 can factor to something that I can use. 98, can I divide it by 7? 14, huh? Maybe. And 14, how about 56? Can I divide that by 56 divided by 14? Oh, nice. So in the top, if I take out 14 out of the top, I'm left with 1 minus, if I divide 98 by 14, I'm left with 7 xy squared minus, if I take 14, 4 minus 4y. On the bottom, I got a 14. I'm left with take out 14. I'm left with 7 x squared y plus 4x. So these cancel out. So our final derivative is 1 minus 7 x minus 4 y over 7 x squared y plus 4x. That's my dy dx. Simple, 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 right? No, maybe not so. Quite the pain. That was number 4. Let's jump to number 5. Number 5. That is equal to, they give us 3 y to the second, 5 minus 2 over 5x plus 2. And ask you to find dx. I'm going to do this as implicit differentiation. Dy dx. We're going to just try to find the dy dx of each part. This is like a constant, so I'm going to take the derivative of this, which is 2y dx. That's that. On this part, I'm going to separate this into 5x. If I take the derivative of this with respect to x, I'm going to put it this way. 5x minus 2. I don't like denominators, remember I told you, so I like the numerator. I'm allowed to do this as long as I remember to put the minus 1 up here. So the derivative of that part would be first times the derivative of the second plus the second times the derivative of the first. So let's do that. First, derivative of the second. The derivative of the second will bring the negative 1 down. Keep these side the same. Take away 1 from negative 1, that equals negative 2. And then I'm going to multiply that times the derivative of the inside. 5x plus 2, 5x plus 2 is just 5. That's the first part. First times the derivative of the second. First times the derivative of the second. Now I'm going to do plus the second, which is 5x plus 2 1 times the derivative of the first. The derivative of the first is just 5. So let's simplify this a little bit more. This is 6y dx is equal to dy dx is equal to multiply this times the negative 1. Do so. Yeah. This times the negative 1. This side is multiply all the way across, it's negative 5. The front is 2 in parentheses. And then this is for this part is negative 2. So see on the bottom 5x minus 2 or plus 2 to the second power. I was hoping these cancel out, but they don't. Plus 5 over 5x plus 2. Yeah, 5x plus 2. Is there anything I can factor out that would make this better? Maybe, but let me solve this for, let me change this a little bit. I still have to solve for dy dx. So I'm gonna divide both sides by 6y. Cancel this. So I'm gonna divide this side by, which means I'm gonna multiply by this whole thing by a 1 over 6y. So what that means. Cancel each other out. So this side, let me see if I can simplify the inside. I wish I could add these two together, but I can't because they don't have a common denominator. If I made this common denominator with this one, I would multiply 5x plus 2 times 5x plus 2, which would give me this. But then I would have to do it to the top. Let's see if that works. Let's leave this the same. Minus 5. 5x minus 2 plus, to change this to plus 2 to the second power, what I did was I multiplied this by 1, the 1 being 5x plus 2 over 5x plus 2. I'm allowed to do that. This makes this 5x plus 2. And all of it over 1 over 6y times 1 over 6y. I'm going to try to simplify this just a little bit. I'm going to distribute here, see if hopefully something comes out. Here I'm left with, I'm going to put it over here for space sake. This here is going to be a negative 25x plus 10 plus 10, negative 20x plus 10 plus, this is 25x, that's good, plus 10, plus 10. That's on the top. The bottom is 5x plus 2 squared, all that times, all that multiplied times 1 over 6y. Actually, let me put it, notice the minus 25x and 25x cancel out. On the top, we're just left with 20. 20 over 5x plus 2. But we're still multiplying that times 1 over 6y. That's still a little simpler than that with dy dx. Let me simplify just a little bit more. The top stays 20. The bottom x plus 2 times xy. Let me see if I know what y is up here. No, that's good enough. So that's the final answer. 20 over, in parentheses, 6 bottom derivative. Yep, that makes sense. Let's try number 6. Number 6. Why number 6? Number 6. It gets a little bit easier now. X is equal to the secant of y. You take the derivatives of x's and y's are in different places throughout the whole problem. So we just, the derivative of x is 1. The derivative of secant of y is, the derivative of secant y is actually secant y tangent y, I think. Secant y tangent y. Let me verify that just in case. It does look familiar, but let me verify. Yeah, yes. Secant x tangent x. Let's check the work just in case. And then the derivative of the inside, which is dy dx. So the derivative of secant y is secant y tangent y, but then we need the derivative of y, which is dy dx. How do we solve for that? Well, we divide both sides by, to leave the dy dx by itself, we divide both sides by a secant y, tangent y. That cancels each other out. What we just saw, we have to do the other side. So dy dx equals 1 over secant y tangent y. There's an issue here. So 1 over secant. I know this trigonometric identity. I should know it off the top of my head, but I do not. 1 over secant is cosine. And 1 over tangent is cotangent. So our derivative that's the one. Relatively straightforward. I have to remember there's no other way to write it. Secant is 1 over cosine, so this is cosine. 1 over tangent is cotangent. That we have to memorize. Somewhere around that one. Number 7. They give us the function x plus cotangent of xy equals 6. Can we do the same thing? We just need, because it's the x's and y's are distributed throughout, we have to do a piecemeal. This is 1. The derivative of cotangent, I'm going to take the derivative of cotangent and then take the derivative of the inside. The derivative of tangent is negative cosecant squared, the inside alone. Now we take the derivative times the derivative of the inside. The derivative of the inside is first times the derivative of the second plus the second, which is y, times the derivative of the first, which is just x. And then the derivative of 6 is 0. Let's see. I want to get rid of the 1, so I just subtract the 1. On this side, it goes to the other side. The way to get rid of the cosine here is to divide it by a cosecant. I'm going to divide negative cosecant on this side. xy. So that out. So that out. So we're left with x y dx plus y. You can remember the minus one we put on that side. And then we divided everything by a cosecant squared xy. That is a trigonometric identity, but I forgot what it was. But this goes with cosine. Where am I? Oh yeah, that stays the same. Now I subtract a y from both sides. That cancels out with that. And then I divide both sides by an x. Divide that by an x, like that. I'm left with that. This piece here I'm going to simplify. Cosecant goes with sine. So this part becomes negative sine squared xy. It just makes it easy later. Minus y. That's divided by x. I think that's it. Huh? So dy dx is that. Notice that dy dx in terms of this is distributed throughout. Great. More trigonometric functions, but still implicit differentiation. X to the fourth plus sine y is equal to x to the third y fifth. This is again because they're distributed through the problem, we take meal becomes 4x to the third plus the derivative of that is cosine of y and the derivative of y x using the chain rule. This is two functions multiplied together, so it's going to be first times the derivative of the second, which is bring down the 5 y to the fourth, and then the derivative of y, which is dy dx, plus this second is y to the fifth times the derivative of the first. The derivative of the first is 3x to the second, and then derivative of x is just 1. So that stays like that. Now I'm going to do it kind of the same basic idea we've been doing before. I'm going to bring this to the other side, and I'm going to bring this to the other side. That way I have the d one side, and now the 1 dx is that one and that one on the other side. The way I do that is I'm going to take out, I'm going to do it in one swift motion. dx, I'm going to bring this side over here, keep here, subtract, so this is going to be here, it's going to be a minus x cubed times y to the fourth. After I do that, this is going to be a side, and then I took out a dx. Now you're probably asking, but what happened to this one over here? Well, this one I'm going to move on that side. The way I do that is I subtract the 4x to the third. So this part stays. So it's y to the fifth. I'll put the 3 in the front. This is x to the second. Now move that one to the other side by subtracting it. Minus 4x cubed. Now what we did before, divide both sides by this, so I'm left with this is cosine of x. I'm going to put a 5x cubed, y to the fourth. If I divide this by that side out, what I do to one side, I have to do the other side. This becomes cosine of y minus 5x y to the fourth. I really can't pull anything out. I can pull an x squared from the top, but I can't plot them. I can't pull no numbers really. So that's as far as I can go. dy dx is equal to second minus 4x to the third all over of y minus 5x to the third y to the fourth. That is the derivative. Number 9. Logarithm, still using differentiation with a geometric function. Notices and y's are all mixed in. So I have to use implicit differentiation. Our dy dx is going to look like the following. The derivative of that is, so we write it again, times the derivative of this part's 4. So this will be 4 e to the 4x. That's that one right there. This is the derivative of the sine times the derivative of the inside. The derivative of the sine is stays the same inside. And now by that comes the derivative inside. The derivative of the inside plus the derivative of x, 1, plus the derivative of 2y, 2, right? The derivative of y. 2 derivative of y, which is dy. That's what that is. So we do have a dy dx here. I'm going to divide both sides by a cosine x plus, and I'm just x. So this side becomes 4 to the 4x sine of x plus 2y. That's 2. 1 plus dy dx. Now I subtract. I'm left with 4x plus 2y. That's equal to 2y. 2 dy dx. Divide both sides by a 2. Here by a 2. That becomes 1/2 times 4e to 4x over cosine of x plus 2 minus 1. Multiply the 2 all the way x. I'm left with 4 over 2 here. So the 2 is going to, so the top is going to be 2. The bottom, I multiplied 2, but it got canceled out. And the bottom on this one, I'm only left with of x plus 2y. Now I'm going to multiply the 1 negative 1. That just becomes, and that is my dy dx. Number 10. The second is the 9 dy dx equal to x plus y dy. Bring down the 2, that's 4x, take away 1. This becomes 2y dy. Constant is 0. I subtract the 4 sides, so I'm left with 2y dy dx is equal to negative 4x negative 4x, divide both sides by 2y. The 2's cancel out the top, so I'm left with minus 2x y. That I guess you could technically make it all in terms of x, because this can be solved for y. If I take y, I subtract 9, I can subtract a minus 2, and I can take both sides. So that is technically my y. So I could plug it in to make it look like this. Minus 2x but I don't like radical, so I have to multiply the radical on the bottom times the radical on the top, this right here. If I do that, the top becomes minus x square root of 9 minus 2x squared. A radical with the same as the radical on the same, that comes out to 9x squared. So that is another version. Solve for back in, that's what they want. Either way it'll work. For 11, we're almost done. Number 11 is super long. They want the second derivative. Y, that's equal to 60. They want the second derivative. And then they want the second derivative at 2, what the value is. I want the second derivative. The first derivative, for us to find the second derivative, we first have to find the first derivative. So let's find the derivative of this using implicit differentiation. Dy dx derivative. We're going to take this and we're going to solve this for first derivative plus 3 dx equals. And now we know what we need to do. We need to take and goes to the other side, then divide 3. So our dy dx, after I subtract, this goes to 0. After I subtract, because any constant goes to 0 when you take the derivative. When I set the 3 to the other side, divide 3y, the 3, and the positive 3 on the bottom make this minus. I divide it through 3y squared. I'm going to get a y squared. Again, the 3, when I subtract, and then I divide it by 3, the 3's cancel out, and there was still a negative there because this became negative when I moved to the other side. So this became my first derivative. Now for my second derivative. Before I do that, I'm going to change it to what I do because I don't like fractions. I change it to this. That is the same. I can move that to the top as long as the exponent. So the second derivative is the second times the second times the root of first. The negative 1 is on the outside. So it's the first times the derivative of this plus the second, which is y negative 2 times the derivative of first. The derivative of first is 2x. That's how we solve second derivative. First times the derivative of the second times the second times plus the derivative of the first. There it is. Now let's simplify this a little bit more. This becomes a 2 front on the top and a y third on plus the 2x on the top and a y second on the bottom. I can factor out, if I factor out, you know what I can do, I can factor out a 2x from the top and a y second on the bottom, but I don't know really much. Let's factor out a 2x. And a y second on the bottom. Y second on the bottom. It might file a little bit. If I take 2x, this is just left with, on the inside, I'm left with messed up somewhere here. S2, Y2, and first. Okay. Okay, that's right. Factor out a 2x. This is left with 2x here, like that, plus factor out 1. Left with the 1. Here I'm left with 1. Left for that. So that is my truth. Now for 2, or D, And they want me to second derivative value at 2, 2. So I just plug in the numbers. Plug in the numbers into here. So it's 10 over 2 to the second power. 2 times 2 over 2 plus 1. So this becomes second to the second, that becomes 1. And then the other, this becomes 4 divided by 2 plus 1. So that's 3. G x1 at 2, 2 is 3. Sweet. Now number 12. Whoa. Nice. Monster hand. Okay, number 12, last one. Squared y minus y squared equals 11. They want us to find the tangent at 4, 5. What the value of the tangent is at 4, 5. And what the tangent at the normal is at same. So A would be the tangent. Great. Implicit differentiation so far. Let's just go with implicit differentiation because we've done these already. It's 2x. That's the same. This is the product rule. First times the derivative plus the times the derivative of the first. It's just 1. Then here we have minus the derivative of 2y to the second x. And the derivative is 0. For time's sake, I'm going to combine all the dy's on this side with everything else on the other side, and we'll factor out a dy dx all in one fell swoop. So I'm going to have my dy dx here, and it's going to be all the equation that have dy dx, which is x and minus 2y. And their side, a left-hand side and a these two, this one I'll move to the other side. I'm going to subtract the 2x from that. Now I'm going to subtract y. So now I have then 2x y x minus 2y. And I want the tangent. They want the value, which is the tangent is the slope of the derivative. Actually, we want the equation, but we can use the slope at 4 equals 5. 4, 5. Y dx, again, 5 into the equation to find out what slope is. So I'm going to plug in a 2. It's 2 times 4 over minus 2 times 5. That becomes a minus 8. That becomes 5. That becomes a minus 13 on the top. Minus 13 on the top. The bottom becomes 4 minus 10. Comes out to minus 6. Slope is 13 over. Now we use the equation y is equal to y1 plus minus x1. That's the equation that is tangent to this function at 4, 5. For y1, we know the y5 plus slope is 13 over 6. Our x1 is 4. Simplifying this bad boy, with simplifying all the numbers, distributing everything, I'm left with 13x over 6 minus 11 over 3. Oops. What I did that was I distributed over 6 to that. These distributed, I can add it to the 5. 5 minus that times that would be this. And that stayed the same. So 5 minus came out to 11 over 3. And that is my equation for the tangent. The normal, what's going to be the difference for the normal? Well, the difference is going to be the slope is going to be the negative reciprocal. So if our tangent, the slope for our tangent is 13 over 6, normal, the slope is going to be negative 16. Is the negative reciprocal of the tangent. So we use the same equation, y equals. Now we use this slope as 6. Plug in a negative 4. 4 is x minus x1. I'm actually do this one. Take 5, distribute that. This becomes negative 13. 6 over 13 times negative 4. To do all this mumbo jumbo. 4, the equation that's normal comes out to negative 613 x plus. That's normal at that point, 4, 5. Hope this helps.